Yeah. So based on this, can you figure out the total arterial oxygen content? Total arterial oxygen content. Remember that when you figure out the total arterial oxygen content, you're going to figure out first how much oxygen is dissolved in plasma, and add to it the amount of oxygen being carried by hemoglobin. Okay, so those are two different equations you have to set up. The amount of oxygen that's dissolved plus the amount of oxygen being carried. Oh, absolutely. Absolutely. But they're not difficult to memorize if you actually understand the concept. Who's missing today? It's Chris also. We missing another person today, Chris.
That's unusual.
Yeah, he's usually here. Stellar student. Gambaluka. Gambaluka. I like it. You say Gambaluka, I say
I don't know how
Gambaluka.
to. Yeah, Jam.
It is jam. That's he told me.
Well, she was saying Gam.
Oh.
I was saying Jam.
Yeah, I never actually heard him pronounce his name, so.
Yeah, it looks like jam.
Yeah.
A lot of people just call him Jam.
Yeah, he was here on Saturday with us during the Wasp Massacre.
Somebody died.
Yeah.
What is going on? Like,
There was a bunch of wasps once you.
All right, so to figure this out, let's look at this. Okay, we want to add dissolved oxygen content to oxygen carried by hemoglobin. All right.
Is that minus?
Plus.
Okay, because you said
Okay,
N.
so dissolved oxygen content is your 0.003 milliliters of oxygen per 100 milliliters of blood times the PaO2 times the milliliters. And you multiply that times 90. Okay? And that gives you what? 0.27 milliliters of oxygen per 100 milliliters of blood, or I could say deciliter. Okay? So that's the dissolved oxygen content. The amount carried by hemoglobin. Well, first we figure out the maximum oxygen carrying capacity of that hemoglobin. And we do that by taking the amount of hemoglobin, 10 grams per deciliter, or I could say 10 grams per 100 milliliters of blood. Multiply it times the constant, 1.34 milliliters of oxygen per gram of hemoglobin. So that would be 10, so that would be 13.4 milliliters of oxygen. Okay, that would be the maximum.
Question, down there when you say 100 milliliters blood times what? What are those words?
100 milliliters of blood where?
Right there? Yeah, what is that?
Times millimeter of mercury.
Alright. And then it's by the 0.27 it's milliliters, O2
Right.
over
Deciliter, or deciliter is the same thing as 100 milliliters. I switched on you there. Okay. Now what I'm doing is calculating for that 10 grams, what's the maximum oxygen carrying capacity. By doing this, I figure out it's 13.4 milliliters of oxygen. That's the maximum that 10 grams can carry. How much it actually carries depends upon saturation. But here it's 100% saturated. So I multiply that 100% times 13.4, and I would get 13.4. So then I'd add 13.4 plus the 0.27, and I would get my total arterial oxygen content. So, again, for the dissolved oxygen, it's just a matter of using this constant and multiply times the PaO2. Okay? For the oxygen that's carried by hemoglobin, you have to figure out the maximum oxygen carrying capacity of that hemoglobin and then multiply times your percent saturation.
This is GE.
Got it, number? Feel good?
13.4.
All right, let me run to the bathroom and we'll